Okay, so naturally, now that we're learning something new with integration, it can get mixed with previous things we've learned how to do with integration. So this is an example, for example 4, that does that. And it also has the different type of improper integral where it's the lower bound that's improper. So let's set this up. So when you start one like this, some people use B for all of them. We're going to use A for the lower bound if that's what we're replacing with the limit, just to kind of differentiate between the two. So we're going to go from A to 0 of 1 over square root 3 minus x dx. Now, here's the issue. We don't have a nice, easy function to find the antiderivative of. In fact, you really need to use u substitution for this one. So in theory, I'm just going to kind of come up here, and I'm going to say u is equal to 3 minus x. So du would be equal to negative dx, but I do not see a negative in my original function, so I'm going to make that negative du equals dx, which I see right here. And to avoid getting really messy with our limits, I'm not going to come substitute back in the u stuff. I'm going to try to think of the antiderivative kind of over here on the side and then plug it back in. So this would look like 1 over square root u times negative du if we were doing it as an indefinite integral. So that's the same as integrating u to the negative 1/2, pull a negative out front, which would really give me u to the positive 1/2 over 1/2 plus c, which would really give me, let's see, that would be, divide by 1/2 is really negative 2, and u to the 1/2 is really square root u, and ru is really 3 minus x. Okay, and again, the reason I'm doing it a little different is I don't want to have to change these bounds and then also still deal with the limit. It's just going to make it gross. So if we can go ahead and find the indefinite integral form of it, it just will make it a little bit easier to do the improper part. So I'm going to rewrite this as the limit as a approaches negative infinity of our antiderivative over here, negative 2 square root 3 minus x. I'm no longer going to put plus c because now I'm going from a to 0. So the limit as a approaches negative infinity, of negative 2 root 3 minus 0, which is just going to be 3, minus negative 2, or plus 2, root 3 minus a. So if I'm plugging in a negative infinity, or, well, I'm not really plugging in. If I'm finding the limit as a approaches negative infinity of this expression, the negatives are going to turn into really like a plus infinity, so it's not approaching anything, right? So the square root of a number that's getting bigger and bigger, it just gives us a bigger and bigger output. So this is really negative 2 root 3 plus infinity in a sense, right? I don't love when we write that because that's not really a thing, but the point is that it's going to diverge. It's not going to converge to a specific answer.